Alright, no? So once again guys, welcome po sa ating video. So let's continue the mock test guys to in signal spectra and signal processing. So we will solve a problem under the topic continuous time Fourier transform. So here's the question guys. Consider an LTI system with impulse response given as h of t equals sine of 4 of t minus 1 over pi of t minus 1. So determine the output of this system, okay, y of t. Okay, the output of the system, y of t for an input x of t equals sine of 2t over pi t quantity square. Okay. So, if you have an LTI system, okay, paano ba natin kinukuha yung output ng isang LTI system, guys? How do we get the output of an LTI system? Okay. So for an LTI system guys, no, so the output, ano kung review lang natin ha. So yung y of t natin is simply equal sa x of t, okay, and the operation is convolution ng h of t. Okay? Well, we can do the convolution operation, but as you can see on the functions, medyo mahirap siya, no? Okay? So, if we will do the manual solution for getting the convolution, that would be difficult. Okay? So instead, no, we'll be using the property. Okay? Meron kasi tayong property, guys, sa Fourier transform. And what is that? Okay, yung property natin sa Fourier transform, no? So let's say, guys, no, we want to solve, no, for the x of t. Okay? Convolution kay h of t. So this is the convolution property guys no ng Fourier transform. So the convolution no in time domain is actually equal sa multiplication no in the frequency domain. So it's just x of omega multiplied by h of omega. So in other words guys no we just need to get okay? We just need to get the uh we transform CTFT no ating h of t as well as our x of t. We multiply them and the result, we will transform it back to y of t. Okay, so yeah, that's what we're gonna do. Okay, first is let's get muna no yung sa h of t. All right? So ano yung h of omega? Okay? Kaya lang again, property based no yung magiging solution natin instead of doing or getting the Fourier transform manually. No, so what will be the solution? Okay, what would be the solution? Okay. So instead of directly getting the h of t, no? So let's find first the CTFT of what? Of sine ng. Yeah, so we have sine of what? Sine of, okay, 4 of 40. 40 na lang muna guys, no? So sine ng 40, okay, all over pi t. Okay, sine ng 40 all over pi t. Okay, no? So, in terms ng mga Fourier transform pairs, so walang direct po ito. So, ang gagawin natin instead, okay, what we're gonna do instead is, di ba may pi tayo sa denominator? So, what we actually do here is, we move out this pi here, okay, and then we will put 4 here. Okay, pero siyempre dahil naglagay tayo ng 4 para ma-balance, we need to get or we need to put 4 also in the numerator. Nagets? Ayan, no? So, ganun yung nangyari, guys, ha? So, we move the pi on the side. Okay? We move the pi on the side. Tapos, naglagay tayo ng 4 sa denominator para maging sampling siya. Okay? So, this turns to be what? Okay? So, ito ngayon, guys, actually, so, this is what, no? So, this is simply equal sa sampling ng 40. So, this is sampling ng 40. And what is the Fourier transform, guys, no, ng sampling? Okay, the Fourier transform of the sampling is pi over A. Okay, so we have pi over A, guys. So, pi over 4. Okay, rect function ng omega over 2A. So, yan, omega over 2A. So, omega over 8. Omega over 8. But don't forget, guys, that we have the factor 4 over pi as a constant. So we also need to put that one, no? So may 4 over pi ka dun. And as you can see, no, this would actually cancel. this would actually cancel. So, bali, rect ng, ano lang guys, rect ng omega over 8. And what is that, no? Pag ginraph po natin. So, what is this pag ginraph po natin? Let us graph this one, guys. Shall we? So, gagraph po natin. So, ano po itsura ng rect ng omega over 8? So, ang itsura niya, guys, is rectangular pulse. Since nag-cancel na tayo, guys, no? Okay, yan. So, since nag-cancel tayo, ang implication nun is that 1 na lang yung magiging amplitude. So, this is 1, ha? So, this is 1. Okay, and 8 siya. So, ibig sabihin, this is from 4 to minus 4. So, ganun yan, guys, no? So, this is a rectangular pulse from minus 4 to 4. Because this is yung denominator no sa kung nare-recall nyo, is the overall duration. Okay? So, yan siya. Okay. Yan, no? So, this is our result. But, hindi yan yung kailangan natin, no? So, ang kailangan natin, guys, is h of omega. So, what is h of omega? So, h of omega is simply what? Okay? So, what is h of omega, guys? So, ang h of omega, as you can see, is the time-shifted version. Okay? Time-shifted version, no? Nung hinanapan natin ng Fourier transform. Okay? So, therefore, guys, no? Ano yung ating h of omega? Okay? Kasi ito yung ano hindi pa time-shifted eh. So, pag time-shifted na, okay, bale, so let's say, guys, that, ano, no? This whole thing here, bale, ang kailangan natin is yung time-shifted version niya. So, let's say, guys, that para madali lang makita, no? Although, not necessary, pero para madali lang makita, so let's say this is any letter G. So, let's say this is G of T. And this is G of T. So, kung kailangan natin is yung H of T, okay, which is equal sa G of T minus 1. Yan. Ibig sabihin, no, yung original na given na, ang kailangan kasi natin is yung time-shifted na G of T. Kasi yung inanapan natin ng Fourier transform, hindi pa yung time-shifted eh. So therefore, yung H of omega, ayan, so yung G of T minus 1, what would be the Fourier transform of this one? So yung G of T minus 1 is simply equal dun sa ano, no, G of omega pa din. Okay, G of omega pa din, pero may multiplier na e to the negative j omega. Okay, frequency, time shift property. Okay, ng G of omega. Okay? So, if this would become H of T, so yung Fourier transform niya, is simply equal sa e to the negative j omega, okay, rect. Okay, rect ng omega over 8. Omega by 8. So, what's that? What's that? Okay? So, kung i-graph natin, guys, anong itsura niyan? So, actually, ang itsura nun is kaparehas nung kanina. Kamukha nung kanina, guys. Right? Pero this time, ano magiging amplitude? Okay? So, very the same, no? So, yung magiging itsura niya, guys, this is the graph of h of omega. This occurs from negative 4 to 4 din. Okay? So, this is 4. And this is minus 4. But the amplitude is e raised to negative j omega. So, that is the amplitude, guys. Okay? So, this is your this is your h of omega. So, tandaan nyo yung drawing, guys. Okay? Kasi re-recall natin yan later. Okay? So, naintindihan yung ginawa. Naintindihan yung process. So, first is, we solve for the CTFT of G of T muna. Okay? Yung hindi pa time shifted. And then, we found out the value of that. And then, gumamit tayo ng time shift property. Okay? To be able to get, the, CTFT of H of T. Which is yan. Yan yung H of omega natin. Okay, guys? Alright. Sige. Now, okay, no? So let's let's have x of t naman. Okay? So yung x of t natin, okay, ito naman yung hanapan natin ng Fourier transform. So sabi dito, no, the value of this one is sabi dito we have sine of 2t over pi t quantity square. So, do you agree that we can write this as sine of 2t? And we can write this as sine of 2t, okay, all over pi t, okay, multiplied by, dahil naka-square siya, we can actually multiply it by it's the same, very the same value, okay, over pi t. Correct. Yes. So let's say naman guys no that this one is ano bang letter ang gamitin natin? So let's say x sub 1 na lang. Okay? So x sub 1 of t. So this is also x sub 1 of t. Okay? So ito naman, ano naman gagamitin natin dito, no? So multiplication, no? So what is the multiplication property of CTFT? So yung multiplication property niya is simply equal sa x sub 1 of t. Okay, x sub 1 of t. Okay, multiplied by x sub 1 of t. Yan is actually, yan ang CTFT niya. Ang gagamitin natin is multiplication property. And that is 1 over 2 pi. Okay, multiplied by the convolution. No, no, yung x1 of omega. Okay, convolution ng x1 of omega kay x2 of omega. Okay, so that is the convolution property. Sorry, the multiplication property. Okay, all right. Right. Okay. So, in other words, guys, no, we just need to find x1 of omega. So, ano yung x1 of omega? So, x1 of omega muna tayo. So, for x1 of omega. Ayan na may solve natin, guys. So, again, what is x1 of t? So, x1 of t is sine of, ano guys, sine of 2t. So, similar nung ginawa natin kanina, guys, no? So, di ba, over pi t to? But instead of over pi, gagawin natin over 2t. Okay? Para maging sampling siya. Tapos yung pi, i-move natin dito. Okay? And then, of course, para ma-balance, may 2 tayo sa harapan. Okay? Ganun yung nangyari, no? So that we can write this as sampling of 2t. So that we can write this as sampling of 2t. Okay? So ano ang CTFT nito, guys? So the CTFT of the sampling function, kagaya nung kanina, guys, is pi over 2. Yan, pi over 2. Yan, rec. Yan, rec ng omega over 4. Omega over 2a kasi, kaya omega over 4. But don't forget na may constant term tayo dito na 2 over pi. Yan, constant kasi kapag ka nag-transform ka, madadala lang siya. So this would actually cancel, right? So that would cancel. So basically, the CTFT of this is what? A rectangular pulse again. This time is from, ano naman, -4 to +4. Okay? Sorry, -2 to +2. Okay, so this is from -2 to +2. So this is x1 of omega. Amplitude is still 1 kasi nga na-cancel na yan ng 2 over pi yung pi over 2. So yun na yan siya, guys. Okay? Now, hindi yan yung kailangan natin. Ang kailangan natin is the product ng x1 of t and x1 of t. Okay? Yun yung hinahanapan talaga ng Fourier transform. And for that one, guys, no, is just simply the 1 over 2 pi times the convolution, okay, of that one. Convolution together with the similar. Okay, convolution itong dalawa. Tama? Okay, no? So, yun yung pinapasolve sa atin. And, yan, no? So, alam natin, guys, no? Ang kailangan natin is yung ano po, 1 over 2 pi, okay, convolution nung x1 of omega, okay, by very the same, no? x1 of omega. Okay. So instead of doing this mathematically, so it is very easy to do this graphically, right? Yeah, no? So this is simply equal sa 1 over 2 pi, okay, convolution nung, ano, itong dalawa. Okay? Oops, sorry. Yan. Convolution yan with very the same signal. Okay. So, convolution ng dalawa, guys. Okay? So, mamaya ko na gawin 1/2 pi, no? So, anong convolution nun, no? Nung pagkaganyan, graphically, kung nare-recall nyo pa. So, anong, ano, no? Convolution ng 2, ah, convolution ng 2 rectangular pulses of equal duration. Okay? The result is ano, 'di ba? Triangular signal. So ang gagawin niyo, add niyo lang yung umpisa. Di ano 'yun, 'di ba? Ang umpisa niya -2 plus -2. So we'll start with -4. Yung dulo naman 2 plus 2. So it means we will end at +4. And then this would become a triangular pulse. Triangular pulse. Kung nare-recall niyo pa sa lecture natin ng convolution, no? Yun. Equal duration yan, guys, ha? So, what will be its amplitude, guys? Kung nare-recall pa, what will be its amplitude? So, yung amplitude niya is just simply the product of the amplitudes nung dalawa. Bali, 1 times 1. 1 times 1. Okay. Tapos, yung duration natin. So, ano ba yung duration natin? That is, what? From -4 to +4. Okay. Kaya lang, over 2. Okay. Kasi triangle yan eh. Right? Over 2. So, bali, bali 8/2, right? Yan, no? So 8/2. So that is 4. But take note, guys, that may 1/2 pi ka sa labas, right? So ibig sabihin, guys, no, yung overall niya, di-divide pa by 2 pi. Again, yung over 2 pi is because may 1/2 pi sa labas, no? Okay? May 1/2 pi sa labas. So let me erase this, guys, ha? Or maybe, I don't know, erase this muna. Yun, no? So, 4/2 pi, right? 4/2 pi. So 4/2 pi is uh 4/2 pi is 2/pi. So the height of this is 2/pi. So this is x of omega. So this is the graph of x of omega. Again, saan po nanggaling yung 2/pi? So yung height kasi, guys, is ano, no, product nung dalawang 1. So bali 1 multiplied by 1 multiplied by the whole duration, guys, which is 8. Yan, over 2. Yan. Tapos, multiplied by 1/2 pi kasi may 1/2 pi na factor ka dun sa convolution property or sa multiplication property. 2/pi. So, doon po nang galing, no, yung 2/pi. Okay. So, ayan, no? Alright. Next. All right, no? So here's our x of omega. So finally, no? Okay, what would be our y of omega, guys? Okay, y of omega. So y of omega is simply the product of h of omega and x of omega. So yeah, so let me rewrite, no? So this is simply the product of x of omega multiplied by h of omega. So we already know our x of omega, no? So this is a triangular pulse, and uh our h of omega is a rectangular pulse, no, from the previous slide. All right. So let me just copy this so I can bring it to the other side, guys. All right. Yan. So ito siya. Yan. And then we will just multiply this with this one, guys, no? So we will just multiply this with this one. So multiply nyo lang guys. Now, since this is a triangle, so bali pares naman sila ng duration no, from -4 to 4. So what will be the result of this no if you multiply this? So multiply mo yung rectangle by a triangle. Okay? So the result would be what? The result would be what? Okay, no? So, ang mag-iitsura niya, guys, kasi ano no? The value of this is e raised to negative j omega from -4 to 4. And this value is varying, no? From -4 to 4. Okay, no? So, basically, pag pinag-multiply mo yung dalawa, okay, the result will be actually similar to x of omega. Kaya lang may e raised to negative j omega na factor. Nagets nyo guys? So the result of this is a triangle. Okay, a triangle guys. But naka-multiply kay e raised to negative j omega kasi, okay, kasi 'di ba? If you will remove this, kaya wala siya, 'di ba? The amplitude of this is simply 1. So 1 times this triangle from -4 to 4, no? 1 ang value niya palagi. Kumbaga parang x of omega times 1. So the result of is x of omega. Now, here comes e raised to negative j omega, okay, na imumultiply mo sa kanya. So, bali, in other words, guys, no, and if you understand what I'm saying, so in other words, no, this is simply equal sa x of omega. The result is simply equal sa, okay, x of omega e raised to negative j omega. So, here's the answer. Okay? Here's the answer. Okay? So, ano ang ano nun guys, no? Ano ang CTFT nun, no? So, if this is e raised to negative j omega, x of omega, so sa kabilang side, this is simply x of t minus 1. Okay? Sa kabilang side, this is simply x of t minus 1 by time shift property. By time shift property. But what is x of t? Again, so yung x of t natin is simply equal sa quantity sine of, ano guys, sine of 2t. Okay, all over pi t, quantity square. So, yung x of t minus 1, which is equal sa y of t, is equal sa, and kasi guys, no, ito yung y of omega, right? This is the y of omega. Okay, which is the product of x of omega and h of omega. Okay? And, sorry, hindi siya over, no? Baka akalain nyo over. Wait, guys. Yeah, yan na lang. Okay, no? Y of t. So, balita time shift lang natin, guys. In other words, a time shift lang pala, no? So, we have sine of 2t minus 1 all over y ng t minus 1 whole square. Whole square. And that is our answer. That is our answer. Yes. Yes, sir. All right. All right. Okay, no? So, ayan. Ito po yung solution on this problem. A little bit long. Pero kung sanay naman kayo guys, no, it can be easily solved. All right? Okay. So, now for your homework guys, no? So this is the homework question. Very much related no to the previous example or the part of the mock test. So, homework. So the impulse response of a continuous time LTI system is given as, ayan. So h of t equals 2 rec of t over 4. If y of omega represents the Fourier transform of the output of the system, okay, with y of omega equals h of omega sine of omega, solve for y of 2. Okay? So, yung ginawa natin previously, almost ganyan din yung process. This one is a little bit easier, guys. So, comment your answers, guys, in the comment box. And see you guys no sa next video. Bye!